Hello, and welcome to Diaphantine. This is Module 1, Unit 1, What is Arithmetic? So, in order to understand what arithmetic actually is, we need to understand the general structure of how mathematics is laid out as a subject. Now, when you go to school, you might take numerous classes. In fact, you probably do. You take, you take English, yeah, you take reading, you take geography, and then so on and so forth, right? There's multiple things you take. And then all of these things combined are your general education, right? This might be whether it's elementary school, middle school, high school, college. Um, they comprise your general education. There's many subjects in one education. Similarly, mathematics works in a similar way. So mathematics as a whole is comprised of arithmetic, algebra, calculus, and many, many more. And so this is mathematics. So in the way that education is comprised of many subjects, mathematics is comprised of many topics within the subject. Uh, Now this can be named many different things. They can be named topics. They can be named subfields, just fields generally, and many other things. But the important thing to note is that they are contained within mathematics. So if we shift down a bit here, mathematics has a very linear structure. So we can think of this as like a tree diagram. So arithmetic is at the bottom of this tree. And then maybe you make your way up here. You have algebra. The algebra 1 is pretty common. Then geometry here. And draw that a little bit better. Algebra 2. And then these might converge. You have like trigonometry. And then, so on and so forth. But what's important to note is that arithmetic is at the bottom. And the reason it's at the bottom, and the reason why it's so important, is it's what gives you all of the tools you need in order to work your way up into the more complex subjects, or topics, or subfields, whatever you want to call them. And so arithmetic has a very famous title, and we'll write it out just to hammer it home. It is the fundamental course in mathematics. And it's important to note fundamental here. Fundamental meaning it underlies everything, right? So if you don't know the concepts in arithmetic, you're not going to be able to move on to algebra 1. And similarly, if you don't know the concepts in algebra 1, you're not going to be able to move on to geometry or algebra 2, and so on and so forth. And mathematics is like this intentionally, right? The way it works is you introduce a concept. Let's be abstract here. We'll call it concept A. And then you prove it to be true. You say, yep, that's definitely true. And then you use it. Say we'll have another concept here, concept B. And you'll use these two things. You'll put them together. You'll join them together like this. And put A and B. And out will pop concept C, right? And then maybe you have use A and B again. This time you use them in the opposite way. So you have B here, you have A here, right? It's a different orientation. And this is concept D. And now you can use these two things, and you can have C and D, which you call E, right? And so you can build these building blocks from, we just started with A and B, but from A and B, we got C and D, and then we use C and D to get E. So from A and B, we got C, D, and E. And these are just concepts, right? They can be anything, right? A might be 1 plus 1 equals 2. B might be 2 plus 2 equals 4, right? And from that, we get another conclusion, C, D, and then finally E. And this is true all the time. In fact, if you've taken a calculus class, you're going to be taking calculus, you want to take calculus, whatever the case may be, calculus, there's a saying that says, you go to calculus to finally fail algebra. And the reason is because calculus really is just a advanced algebra course. And you just do a whole lot of algebra in it. There's only a very few new topics that get introduced in the subject. But you need to know all the building blocks beforehand in order to take that course. And the same is true for everything around arithmetic. Arithmetic gives you these fundamental building blocks, A and B. And then from there, in algebra, you can create C and D, and then finally in calculus, you can create E. And they're all just lead back to A and B. And this is really nice and really satisfying because it allows you to just know some rules, and then any complex equation you come across can be reduced down to these simple rules, right? If you don't know the answer, you don't know the theorem or the equation or whatever the case is, you can just simplify it again and again and again into something you do know, and then you work your way back up. And this is often where students might fall apart, or maybe their teaching isn't that good. It's because we're taught to memorize at A and B, and then memorize C, and then forget about A and B, right? Oh, we know C, we don't need to think about A and B. Well, what if you forget C? Well, then you need to rely on A and B and build up to C again. And this is a really critical thinking, and it's what mathematics is founded upon. So that's why arithmetic is the fundamental course, and that's why it's the fundamental topic in mathematics. And every other course, no matter how complex, even in graduate level mathematics where you're looking at real analysis and it doesn't even look like math anymore, you're still using these fundamental concepts introduced in arithmetic. And so they're extremely, extremely important, both in high-level engineering mathematics and quote-unquote lower level or everyday life mathematics, where you need to add together two things on your grocery list. So that's why arithmetic is important. And yeah, I hope that was a good explanation. In the next video, we're going to be talking about value, numbers, and digits, why they're different, what they have in common, and just how they're different from each other. So I'll see you then.